All right, we're gonna start getting into the Pythagorean theorem, and this is definitely eighth grade material, but just gonna hit it, and since it goes with this unit with triangles and so forth, is Pythagoras. Some people say Pythagoras did not discover it; it was the Pythagoreans, or that legend has that Pythagoras was so excited for the theorem that he killed an oxen for it and had a party, or whatever. Um, so, but some real life applications of Pythagorean theorem. It only happens for right triangles, but um, some architecture, woodworking, um, roofs, sloped roofs, and stuff like that. Often, a lot of times, people in construction will talk about slope of roof. They'll say like three, 3 to 8 or something like that. When talking about slope, they're talking about the legs of a right triangle. So a right triangle always has legs. I can draw as good as I can. So we have a 90-degree angle. So these are the legs. That's a leg. That's a leg. And this is called the hypotenuse. It's pretty much spelled. I'm pretty sure I spelled that wrong. But a hypotenuse is so these are the legs. So legs, legs, and the hypotenuse is the long side that's opposite of the 90-degree angle. Since 90-degree angle on a right triangle is the largest angle, the side opposite of it is the longest side, and we call that the hypotenuse. So that long side is called the hypotenuse in the right triangle. And so, once again, if you talk to any construction people and they talk about slopes of roof or pitches of roof, call it the pitch, uh, they'll give you two numbers, and that is what they're talking about. And that is, you can basically use that information for Pythagorean theorem. So, what Pythagorean theorem is, you have the values of a squared plus b squared equals c squared. Now, remember, a, b, and c are just variables that represent numbers. So in order for something to be a right triangle, it's got to satisfy that. So we can have something that is a triangle and give you the sides of it, but it doesn't mean it's a right triangle. And so a squared plus b squared equals c squared. That's going to be your right triangle. It has to be equal to each other. And so if we look at a triangle, I'm going to do a very basic one, a 3, 4, 5. So we have let's say that's 4 units. Let's say that's 3 units. This is 5 units. So anything that has a 3, 4, 5 ratio in it, it will always be a right triangle. So in other words, if I have 6, 8, and 10, that is a 3, 4, 5. Right? So a 6, 8, and 10 triangle would also be a Pythagorean triple. Okay. So if we look at this, if when we're talking about squaring something, we're talking about 2 dimensions. And so if you think about this as a square, let me get a blue marker out. Different color marker so you can see this. And I'm going to put a little video here with it's a water video of Pythagorean theorem, and put that in here also. So if you look at this, if we make this 3 units, and make this as perfect as a square as possible. 4 units. Try to make that a square that looks more like a rectangle. And then we look at 5 units. Yeah, that's terrible. As you'll know, Miss Cream is a terrible drawer. But this square and this square equals that square. So if we square this, a 3 by 3, a 4 by 4, and a 5 by 5, this 3 by 3 and 4 by 4 square is the exact same area as the 5 by 5. Okay, we can prove that. So if we plug in 3 here, 3 squared, let me get my other marker out. We have 3 squared plus 4 squared. Does that equal 5 squared? And so we can prove whether or not this is a Pythagorean triple or not. Is this a right triangle? So 3 squared is 9. 4 squared is 16. And 5 squared is 25. So 9 plus 16, does that equal 25? Well, yeah, it does. So since this equals 25 and this equals 25, we know that this is yes. It is a Pythagorean triple. Yes, it is a right triangle. It has to have a 90-degree angle. So we know that to be true. Okay. So let's do another one. Remember, this only works on right triangles. So let's say I have one that is 15 by 20 by 25. So we have these dimensions. Is this a actual right triangle? Well, first of all, we know it's a triangle period because it does pass the triangle inequality theorem, which is the two smallest sides is it larger than the large side, the third large side. So it does. It's 35 is bigger than 25, so that satisfies that. We know it is a triangle, but just because we drew a right triangle doesn't mean it necessarily is. So we have to find out and prove if it's true or not. Is this a right triangle? And so 15 squared, right? 15 squared is 225 plus 20 squared. Or is it 325? 20 squared equals 25 squared. So we got to square those. All right. So 15 squared, 225 plus 400. And 25 squared does equal 625. So we put these two together, and that's 625 equals 625. So yes, this is a Pythagorean triple. Okay, it does work out. Right, so this is true. It does work. It is a Pythagorean triple. It does make sense. It does work there. Okay, so um, let me give you a couple examples here, and you tell me whether these are Pythagorean triples or that they are right triangles. So I'll give you a couple of sides here, and you'll see if this is true. And sometimes you'll even notice, like, hey, Mr. Graham, this wouldn't even make a triangle anyways, because it doesn't satisfy the Pythagorean, the triangle inequality theorem. So if you notice that, you'll be fine. So let's say for A, we have uh, for A, we have is 5. Okay. For B, we have 7. And C, we have 8. Okay. So go ahead and do that real quick. I'll give you a second. So 5 squared plus 7 squared equals 8 squared. So we can find out whether this is actual a triangle. Now we know it makes a triangle because the triangle inequality theorem states 5 plus 7 is 12. 12 is bigger than 8. So therefore, this is a triangle. However, is it a right triangle? And so 25 plus 49 equals 64. And so we can put those together. All right. And so is this the right triangle? So so we put those together. 49 plus 65 would be 60. What? Is that 64? Is it? No, it's 74. So 74 equals 64. Is that true? Does that make sense? No, it doesn't make sense. 74 does not equal 64. And so since it doesn't equal it, this is not a right triangle. It is not a Pythagorean triple. Okay? This does not work whatsoever. It doesn't work. So let's do another one. Let's say um, A, we have 10. B, we have 24. And C, we have 26. Now remember, when you square these, it's just multiplying by itself. There also is that button on the calculator. So if I plug in 10, and there's this little button right here, that little square button. Now you can also use I like to call it the caret button. That's good for the exponent also. You hit the squared button. So 10 squared, and hit enter, and we get 100. When I hit enter, oh, so we get 100. So 10 squared plus 24 squared equals 26 squared. So 10 squared is 100. All right. So 24 squared is 576. Does that equal 26 squared? 676. So add that together. Does that equal 676? Yes, it does. So once again, therefore, we know that this is a right triangle. This is a Pythagorean triple. It does work. Okay, so this one does work. So let me give you a few more examples. You guys will do these, and this will be your work for today. And tomorrow you do quizzes on Pythagorean triples and seeing if it is a right triangle or not. Then Monday we'll get into, finding a missing side. Okay, whether it's a hypotenuse or whether it's a leg, we will find those on Monday of next week, um, and you'll be able to find that information. Obviously, quizzes on it and stuff like that. All right, so so go ahead and find out what this one is. So let me erase this stuff first. A few problems to do here. And I hope you guys are taking notes as you do these videos. Now, obviously, you can watch the videos over and over again. You can even pause them whenever you want to. So that's the nice thing. So we're going to do a right triangle. It is 6 by 8 by 10. So see if that is a right triangle or not. We have another one that is 9 by 5 by 10. So 9. So A is 9 or 5. B is 9. And C is 10. So that's example 1 for your problems. Example 2 for your problems. Let's do one with decimals. Let's try that. And it'll be close. It won't be exact, but it'll have to be close. Okay, so keep that in mind. So 6. B equals 11, and C equals 12.5 here. Number 3. All right. So you're just gonna look at each one of those and see if they are Pythagorean triples. Are they actually right triangles? Okay. So you're gonna find out which one is which, if they're right triangles or not. So problem number 1, problem number 2, problem number 3. Square those. See if your A plus your B, when it's squared, is it equal to C? Okay. So make sure you square them first, then add the numbers together and see if that is true. Take care, guys. Be safe. Talk to you later. Bye.